dot v will open up in AV cos theta, and there will be no way to calculate this, right? But what I can do is I gave you hint also last time. I can take the vector A dot V is equal to AX VX plus AY VY plus AZ VZ. So I can write this like this, and then I will use a three-dimensional wave function into one-dimensional wave function. Like I will write it like this. Please see this. Average of this will be integral 0 to infinity. Huh? What was that? E to the power A dot V into the three-dimensional distribution function phi v and dv, right? This was the case. And now I will write it like this, integral 0 to infinity. So I will write this as one-dimensional function. So I will write it like this. I will convert it into one-dimensional. So it will become minus infinity to plus infinity e to the power ax vx from here ax vx e to the power. And what was one-dimensional wave function, you remember? It will become m by 2 pi kbt to the power half and e to the power. So this will come in the front. So write it like this, integral minus infinity to plus infinity m by 2 pi kbt to the power half. Okay. And then e to the power ax vx minus, what was there?
Beta mv
square by 2 kbt.
So m vx square by
2 kb.
2 kbt into dvx, and exactly same for y and exactly same for z. This you have to understand. Off your mic. किसी का mic on है? So what will this become? It will become m by 2 pi kbt to the power 1 by 2 integral. What is this integral equal to? So I gave you one integral, integral minus infinity to plus infinity e to the power minus ax square plus bx and dx. Okay. So this is equal to under root pi by a e to the power b square by 4a. Yes. So apply this. It will become under root pi by A. So pi by, what is A here? M by 2 kBT into e to the power b square by 4a. So 4 upon m 2 kBT. यही तो है? Into same. Now this is just cancelling. And what is this giving? 2 to the 4. It is giving e to the power ax square kBT by 2m. What here we will get?
Yes, sir.
Ay square kBT by 2m. And what here I will get? A z square kBT by 2m. E to the power a square kBT by 2m. This is the average value. So I hope that you understand that this 3 dimension I have converted it into 1 dimension into 1 dimension into 1 dimension. I have told you na, by
Sir.
correlating 4 pi v square dv to dvx, dvy and dvz. समझ आ रही है बात?
Yes, sir.
And I have used here a square is equal to ax square plus ay square plus az square. Okay? So this was that question. हाँ, कोई कुछ पूछ रहा था क्या?
Yes, sir. Sir, जब 3 डायमेंशन में डायमेंशन 2 डायमेंशन 1 डायमेंशन को कन्वर्ट किया था तो फर्स्ट टर्म में 3/2 नहीं थे पावर फर्स्ट टर्म में m/2 पाई kBT पावर 3/2 था सर.
हाँ.
सर वो किससे कन्वर्ट किया?
तो 3/2 था तभी तो 1/2 into 1/2 into 1/2 लिख लिया.
Okay, sir, I got it.
What is 1/2 plus 1/2 plus 1/2?
Yes, I got it. 3/2. Yes, sir.
Okay. Now, till now, we have only considered the ideal gas with no interaction, if you remember. We have considered that the gas molecules are still not interacting. We have included degree of freedom. We have got the distribution of the velocity. But what is still missing is the interaction. So let us take interaction and let us consider the real gas. And the actual derivation of real gas is not easy. That is done by the concept of partition function, and lot of mathematics is done. But I will use some, a kind of empirical method to derive it. Okay. So real gases, and especially it is van der Waals gas. So now the molecule, there are two molecules and they are now talking to each other, right? There is interaction. So interaction. Interaction. Okay. So one molecule 1 and molecule 2 is not free. There is an interaction potential, and because of that, it will be different from the ideal gas. So in spite of taking the gas to be ideal, in spite of including the concept of degree of freedom, the problem was there that many phenomena, many important phenomena that belongs to gases and liquids cannot be explained using that ideal concept. I will give you a very simple example of liquefaction of gases. Why the gases liquefy below a certain temperature and at some critical pressure. Why the gases liquefy and why they cannot be liquefied at higher temperatures even if you increase the pressure a lot. Why the gases cool down when they are passing through a porous medium. So all these things cannot be explained using the ideal gas concept because the force between two molecules, the interaction between the two molecules, that is responsible for these phenomena. So because of that interaction, these phenomena take place, like the cooling of gas. When the gas molecules are passed through a porous medium, so those molecules, when they are passing through that porous medium, that means they are passing through a very small holes, so they have to overcome the interaction between the molecules. So for that, the molecules have to do some work, and because of that work, some energy is spent, and the overall molecules, they cool down. Okay. So all those phenomena cannot be explained. So I will take a model in which the gas molecules will be interacting. Okay. So if I consider this model like PIVI is equal to nRT, suppose. So this is, ideal gas. This is ideal gas. I means ideal. And now consider some molecules like this in a container. So consider few types of molecules. Okay. Let me consider few types of molecules. One is which is in the bulk, and some are at the corners like this. They are at the vicinity. Okay. So these molecules are attracted by the other molecules, other surrounding molecules like this, like this, like this, and like this. These molecules are surrounded by the molecules like this. So net force on them will cancel. But the molecules which is at the corner, because no other molecule is there to attract, so these molecules in the bulk will attract them, and they will feel a force towards the center. So because of the molecules present at the vicinity, those molecules are attracted towards the center. And the kinetic theory of gas model, in which you understand that the pressure of the gas is because of the bombardments of the molecule on the on the wall of the container. प्रेशर का क्या कारण है? क्योंकि मॉलिक्यूल्स का बम्बार्डमेंट हो रहा है वॉल्स पे, सो दैट इज द रीजन ऑफ द प्रेशर, राइट? प्रेशर का वही कारण है. ओके, सो व्हाट इज हैपनिंग? ये जो विसिनिटी वाले मॉलिक्यूल्स हैं, बिकॉज दे आर अट्रैक्टेड टुवर्ड्स द सेंटर, सो नेट प्रेशर विल रिड्यूस. ये बात सबसे पहले आपको समझनी है कि दैट द रियल प्रेशर शुड बी लेस देन आइडियल प्रेशर. फर्स्ट ऑफ ऑल अंडरस्टैंड दिस. देखो ये बात समझते हो? सो बिकॉज जो कॉर्नर्स वाले मॉलिक्यूल हैं, corner molecules will be attracted towards the center, okay? The corner molecules will be attracted towards the center, so that's why the pressure will reduce. Okay, so if I understand this, it is just like this: 3 is less than 5, yes or no? So I can write 3 is equal to 5 minus 2. I want to make you understand in terms of numbers. Okay, so how I can write this PR? PR is Pi minus alpha.
So
Yes or
the
no?
pressure is basically the pressure on the walls.
What is the pressure? What is your question?
So we are talking about like pressure now. This pressure is like the pressure exerted by the molecules on the walls.
You can tell any other pressure, about any other pressure. If there are molecules in a container, so can you tell me any other pressure that exists?
No, sir.
The pressure is only because of the bombardment of the molecules. We have done it in kinetic theory of gas, right?
Yes, sir.
So PR is equal to Pi minus alpha. ये देखो, ये नंबर देख के समझ पा रहे हो? अब ये जो अल्फा है, it is associated with the, you know, ये जो अट्रैक्शन टुवर्ड द सेंटर हो रहा है, उसकी वजह से जो प्रेशर रिड्यूस हो रहा है, इट इज एसोसिएटेड विद दैट. सो अल्फा इज प्रोपोर्शनल टू द नंबर डेंसिटी, I mean number of moles per unit volume, because more is the number of moles per unit volume, more is the molecules at the corner. And one more time NYB, because more attraction. More attraction towards the center. So this alpha will be equal to some A times N by V whole square. Okay. So your PR will be PR plus A N by V whole square. See this. Understand this point, everybody? And tell me if you understand.
सर
Hmm.
सर हम एन बाई वी वो मतलब सेकेंड टाइम लिया ना, वो क्यों लिए?
फर्स्ट टाइम क्योंकि N by V ज्यादा होगा तो ज्यादा मॉलिक्यूल कॉर्नर पे आ जाएंगे.
ओके सर.
सेकेंड टाइम बिकॉज n by v ज्यादा होगा तो ज्यादा अट्रैक्शन होगा, तो दो बार वो फैक्टर आ जाएगा. तो वन टाइम बिकॉज
Okay, sir.
more n by v, more molecules at the corner. ये दिख रहा है या नहीं? Corner. And 1 n by v because more n by v means more attraction. So write it like I am writing. Arrow बना के, ताकि बाद में भी याद रहे. बोलो, समझ आ रहा है?
Yes, sir.
Yes, sir.
Yes, sir.
सर वो मोर के बाद क्या लिखा है?
More attraction.
जी जी सर.
ऐसे पूरा लिख लो, more attraction towards the center. हाँ? More attraction towards center. Is that okay?
यस सर.
तो यहां तक सब समझ आ गया?
Yes, sir.
So first time we have considered the attraction. So first we consider the interaction in first point. So 2 points we are going to add to ideal gas. First we have included the interaction, and second point is I will include the finite size of molecules, finite size of the molecules, because in ideal gas we considered that the molecules are of zero size. They occupy no space, if you remember. Yes or no? But actually they will occupy the space, so real volume will be greater than the ideal volume. So again write it like this. ये number में लिख देता हूँ so that there is no confusion. So 5 is greater than 3. So what is 5 is equal to 3 plus 2, correct? So what will be VR is equal to VI plus alpha. Is that okay?
Yes, sir.
Yes, sir.
And this alpha is equal to N into B. Number density, I mean number of molecules, number of moles. More the number of moles, more will be the molecules, more is the space occupied by them, and B is the property of the molecule. For example, some molecule will be big, some molecule will be small. So because you will consider them as a sphere, so this B is associated with the radius of that sphere. So now what is VI? PR minus NB. Now let us modify. Let us now modify our result by putting the values of ideal here. So PR plus A N by V whole square into V minus NB is equal to nRT. This is the van der Waals gas equation. This is VR. So we don't put VR or PR. Generally we drop it. But what is this P? Real pressure. And what is this P? This is ideal pressure. This is ideal volume. This is real pressure. This is real volume. Understood this van der Waal concept? Bolo bhai.
Yes, sir.
Yes, sir.
So now, can I erase all this now? Or anybody wants to ask anything? Okay. So let me erase all this. Okay. Now, if you see the ideal gas, it is like this, P and V. We have plotted the ideal gas before also at constant temperatures, but this time everything will change because this time, suppose I write it for 1 mole. So P is RT by V minus B minus A by V square. Before it was P is equal to RT by V. So even right now also, you will get a graph like this if temperature is very high. It will behave like an ideal gas. Like ideal gas में यही होता है. If temperature is constant, you will get a graph like this, right? But if you go below, if you cool it down, then the interactions will become important. They cannot be explained by ideal gas equation. You will get the graph like this. And below, so this temperature where this starts happening is called critical temperature. And below this temperature, you will get the graphs like this. So this temperature is T greater than Tc, and below temperature is T less than Tc. And where this appears first time, a very small. So this is behaving like ideal gas. Even ideal gas equation PV is equal to nRT will give this curve. So this is behaving like ideal gas. But below this critical temperature, you cannot explain it using ideal gas. Now, what is happening here is very, very important. And that can be explained by van der Waal gas. And you can explain the liquefaction of gas also using this curve. Okay. So let me explain you. If you just zoom in to this curve, how it will look like. Suppose I make it little pronounced, it will be like this. This graph is like this at critical temperature or below critical. This is T less than Tc, critical temperature. So what is happening here that the, at this point, the slope is negative. At this point, the slope is positive, and at this point, slope is 0. So slope is negative, 0, positive, then again 0. And these points are very close. So actually, this is P versus V. So actually, del P by del V is also 0. And del 2P by del V2 is also 0. You should differentiate these equation and put it equal to 0. Like if you differentiate this one, what you will get? Del P by del V क्या मिलेगा? Minus RT by V minus P square, and this one plus 2a by vq. This first time derivative. And the second time derivative will give, bolo, 2RT by v minus b whole cube and minus 6a by, bolo, v to the power 4. So put them equal to 0 and get the values of critical constants. So like if you put it equal to 0, this side it will become RT by v minus b whole square is equal to 2a by vq, and this side it is 2RT by v minus b whole cube is equal to 6a by v to the power 4. Now divide these equation. This upon this, what you will get? 2 by v minus b is equal to this upon this upon this. So 3 by v. Cross multiply. So you will get 2v is equal to 3v minus 3b. So v is equal to 3b, and this is called critical volume. Put this value of v here. You will get critical temperature. And put both value here. You will get critical pressure. So critical temperature you will get Tc is equal to 8a by 27 br. This will be critical temperature. और critical pressure क्या हो जाएगा? Pc is equal to a by 27b square. This will be your critical pressure. Okay? And if you put it in this equation, suppose RTC by PCVC, you get 8 by 3. This is very important. For ideal gas, there is no critical temperature. So if you put RT by PV, what you will get? 1. Because PV is equal to RT, right? So this is ideal gas. And this is van der Waal gas. This is ideal gas and this is van der Waal gas. And if you, Maxwell said that it is difficult to understand this part because here what is happening, you are reducing the volume and pressure is also getting reduced. Here it is okay, you are reducing the volume, pressure is climbing. Here is also okay, you are reducing the volume, pressure is increasing. But here it is difficult. So he said, let us approximate this by using a straight line and let these two areas be equal. So this is Maxwell's law of equal areas. Okay. So he said, let us approximate it by a straight line like this. And now he said that we can explain everything like we are reducing the volume, so pressure is climbing up. And now here, without change in any pressure, the volume is suddenly dropped. So he said that this is liquefaction. वॉल्यूम अचानक कम हो गया और प्रेशर सेम है, तो मतलब यहाँ पे गैस क्या हो गई? लिक्विफाई हो गई. और एक बार लिक्विफाई हो गई, so most of the liquids are almost incompressible. So that's why the very large amount of pressure is needed if you further want to reduce the volume. So that approximation is called Maxwell's law of equal areas. Maxwell's law of equal area. So these are small concepts, just we have to remember. So otherwise, if you have ideal gas and your graph is like this, you can't explain these things. You can't explain the liquefaction. You can't explain the existence of critical points. And if you don't go below this critical temperature, no liquefaction will take place. So all that can be only explained by taking this model. Okay. And you can also see here when the graph was like this. Suppose it was like this. No. It was going like this, no? This. Okay. So you can see that at same pressure, if I make this, we will get 3 volumes, V1, V2, and V3. How mathematics and physics plays. So you at a given pressure, you have 3 volumes. Yes. So when you increase the temperature, these 3 volumes become 1. And that gas become ideal gas. And when you decrease the temperature, at a same pressure, you will get 3 values of the volume. Okay. So T less than Tc, this graph will come into picture. V1, V2, V3. For T less than Tc, they all will be real. And if you go for T greater than Tc, so what will happen that V1 will become real and V2 and V3 value will become imaginary because it is cubic equation. So it should give 3 values, but they will become imaginary. You will naturally neglect them. So obviously for ideal gas, T greater than Tc, 1 pressure, 1 volume, the graph will be like this. 1 pressure, 1 volume. But in this case, you will get 3 values. Okay. Then people thought that can we make a model which is better than the van der Waals gas model? So in this only 3/3 cubic power was considered. See, let me tell you. That is called the virial model. Virial. So like you have P is equal to RT by V. This is ideal gas model. Then you have P is equal to RT by V minus B minus A by V square. This is your van der Waals. But if I make a model, so PV, sorry, take V this side. PV is equal to RT is this, and van der Waals will be what? If you have something like this, P is equal to this, so you have to write it like this. Multiply kar do V se. V. Okay? So PV is equal to, एक मिनट में फिर से बताता हूँ नहीं तो कंफ्यूज हो जाओगे. I want a model in which PV is equal to किस टाइप का हो? It is like this: alpha plus beta by V plus gamma by VQ plus dash dash dash. That means all powers are included. So let us fit it with ideal gas. So in ideal gas, what is there? PV is equal to RT. So what is alpha? RT. What is beta? 0. What is gamma? 0. Everything is 0. So you can fit the real gas also. Like P is equal to RT by V minus B minus A by V square. So let us fit it in this virial equation. So I have to write PV is equal to VRT by V minus B minus VA by V square, correct? So it will become RT by 1 minus B by V minus A by V. So it will become, because b is much smaller, so it will become 1 minus b by v to the power -1 minus a by v. Now you understand. It will become RT 1 plus b by v plus b square by v square plus dash dash and minus a by v. Now compare. What is the value of alpha? Bolo bhai. RT. What is the value of beta?
B minus A.
No.
Sorry,
It is
BRT.
RTB minus A. What is the value of gamma?
RT B square.
Beta.
So
What is the value of gamma? RT
B square.
B square. So understood this? It's a previous year question hai. Just compare करके बता दे. So a new equation may be given to you which you have not seen, and they may ask you for the virial coefficients. Okay?
Yes.
So virial model is like general. It is taking care of all powers of volume जिस level तक भी तुम जाना चाहते हो. जबकि ideal gas में power 1 है और real gas में power 3 है. Okay? Okay then. So I'll stop here. Any doubt?
Sir?
Hmm.
Sir, in the previous question, the Maxwell law of equal areas, we said that. Why equal areas?
No, that is law, na? He said that let us consider to be equal and let us consider that to be straight line.
Means in the graph we are taking the equal area. That's
Yes,
why.
yes,
Okay, okay, sir.
And so that is approximated. Whatever effects are upside and downside, that is approximated by a straight line.
Okay, sir.
Okay?
Yes, sir.
सर ये virial equation का significance क्या है?
किसका? वीरियल का? कि भाई जैसे तुम मान लो आइडियल गैस में फिटिंग कर रहे हो तो तुम लिमिटेड पावर्स ले रहे हो, राइट? तुम वंडर वॉल में कर रहे हो तो भी तुम लिमिटेड पावर्स ले रहे हो. इसमें तो जितने ढेर सारी पावर्स हैं, जितनी भी तुम्हारी एक्सपेरिमेंटल चीजों को फिट करें, फिट करके अल्फा बीटा गामा की वैल्यू लिख लो, तुम्हारा मॉडल तैयार है अप्लाई करने के लिए, रियल गैस को अप्लाई करने के लिए. तो इसका सिग्निफिकेंस इसलिए है कि इट इज काइंड ऑफ अ जनरल मॉडल. ओके?
Yes, sir.
समझ आया सॉर्टन?
ठीक है सर, thank you.
ओके.
Yes, sir.
ओके देन, थैंक यू सो मच.
Thank you.